Okay, so I'm going to be solving problem number 10 from the chapter 7 homework. So the question is, the tub of a washer goes into its spin-dry cycle starting from rest and reaching an angular speed of 5 revolutions per second in 8 seconds. At this point, the person doing the laundry opens the lid and a safety switch turns off the washer. The tub slows to rest in 12 seconds. Through how many revolutions does the tub turn during the entire 20-second interval? Assume constant angular acceleration while it is starting and stopping. So yeah, basically it's just a washer and it's rotating with 5 revolutions per second in 8 seconds. And then the other time it's 12 seconds. Okay. For 5 revolutions per second for 12 seconds. So to solve this, I'm gonna divide it into 2 parts. So part 1 will be dealing with the 8-second interval. So first I'm gonna write down everything that we know. So angular velocity initial is 0 revolutions per second. Time 8 seconds. And then angular velocity final is 5 revolutions per second. And since we need to find the total revolutions, we'll be solving for theta. So the kinematic equation that I'm going to use is theta equals 1/2 angular velocity initial plus angular velocity final times time. So now you just plug everything in. And then if you solve for that, then you will get 20 revolutions. So that's so it's 20 revolutions in 8 seconds. And now we have to solve for the 12-second interval. So I'll call that part 2. So again, going to write down everything that I know. Angular velocity initial 5 revolutions per second, since it's starting out at 5. And then the final one is going to be 0 revolutions per second, since then we stop the washer, so, velocity will be 0. Time is 12 seconds, and theta is what we're solving for. So again, going to use the same kinematic equation, theta equals 1/2 angular velocity initial plus angular velocity final times time. And now I'm just going to plug everything in there. Oops. It should be reversed. And then if you solve for theta, then you get 30 revolutions. So now we know how many revolutions there was in the 8-second interval and how many there was in the 12-second interval. So then all we have to do is add them for the 2 intervals to find that for the overall 20-second intervals there was 50 revolutions, and that's the answer. So, yep, that's pretty much everything. So yeah.